Hello class. The purpose of this module is to explain some background about Unix and C. Before high-level programming languages were invented, there was assembly language. Assembly language is a short set of instructions for computers' hardware. It can be read by humans, but it's difficult to understand the meaning unless you're intimately familiar with the language. The example is the set of instructions that are used to perform the operation A equals B plus C. High-level languages were invented to generate assembly language code automatically using instructions that look like natural language. High-level languages greatly simplified general-purpose programming. Although assembly language programmers felt that hand-coded assembly language was superior to assembly language code that was generated by a program. What is C? Well, C was not the first high-level language, but it has a long pedigree. It was developed in 1972 at Bell Laboratories by Dennis Ritchie, who was co-developer of the Unix operating system. C was created to run on Unix. Here's the evolution of C. The first high-level language, which was developed in the 1950s for scientific and engineering applications, was Fortran. Fortran was revolutionary because it reduced the number of lines of code by a factor of 20 over hand-coded assembly language. More sophisticated languages followed in the 1960s, and then the languages became simplified. CPL was less abstract, easier to use than ALGOL. And then CPL was simplified further with BCPL. An even more simplified version was simply called B, developed by Ken Thompson of Bell Labs. Maybe it was a little too simple. Features were added back in 1972 to create C from B. C is a highly structured language. It's very efficient. It's modular. It's easy for multiple programmers to combine separate codes into one program. It's a powerful general-purpose language. It's a high-level language because a person can read it like natural language. It's a low-level language because it works close to the hardware level if the programmer desires. It's a paradox that C is both a high-level and a low-level language. Because it's powerful and easy to use, perhaps this is why C is still one of the most popular programming languages since 1972. Unix is an operating system, rather like Windows, but much older than Windows. It was designed in the 1960s to allow scientists to share data and work, long before personal computers. Unix supports multi-users and multitasking. It was very advanced for its time. Programs that allow users to communicate with Unix are called shells. The Unix file system is hierarchical. This shows the hierarchy of navigation. The user can navigate up and down through the directory structure using the cd command. Here are some Unix commands that are used to interact with the shell. The commands consist of a keyword, which may or may not have switches or arguments. In these examples, the Unix prompt is represented by a $sign followed by greater than. The command ls lists all the files in the current location. This is probably the commonest command that you'll use. If you add the L switch, ls space -L, you get a file listing in long format, so you can see more details about each file. ls space -L space and the name of a directory will list the contents of just that directory. Here you can list the contents of that directory that match the suffix .out. Here we use the asterisk as a wildcard. So we can list files with ls. We can create new directory with mkdir, make directory. We can change directories with cd. If you're not sure where you are, you can type cd space tilde or just plain cd to go to the home directory. You can move up one directory in the hierarchy with cd space dot dot. You can stack them with slashes. So to go up two directories, it's cd space dot dot slash dot dot. And you could extend that to 3 directories as well. More useful commands: rm removes or deletes a file, rm space -r removes or deletes an entire directory. If a directory is empty, you can use the rmdir command, remove directory. You can move a file from one name to another, in other words, rename it, but I don't do that. I copy the file using cp, and then if I want to delete the original, I use rm. mv combines the copy with the remove, but if something goes wrong, then you might remove a file that was not copied. You can use the command more to view the contents of a file without going into the VI editor. Cat or catalog does the same thing, and chmod changes file permissions. Another very useful command is pwd, present working directory. If you're not sure what directory you're in, you can type pwd and it will give you the details. Man followed by a space and the name of another command will give you helpful information about that command. An exit will log you out from a session. But you don't have to type every command that you need. You can access your entire command history for weeks and weeks through the up and down arrows. Press the up arrow to repeat the last command and keep arrowing up to scroll through the entire history of commands. The asterisk is a wildcard. For instance, to list all files in the current directory that end with the extension .c, you can type ls space *.c. Don't do this unless you really want to remove all the files in the current directory. rm space *.*. So to recap, you're going to decide on how to approach the problem, and create an algorithm and a plan of attack. For example, you'll show the starting place. You'll display some instructions to the user. The user will make a choice and enter some data. You'll display a response and indicate the ending place. A flowchart might look something like this. You've got a starting block in an oval shape, input and output blocks as parallelograms, a decision diamond, followed by, in this case, a greeting in the user's choice of language, and that's the end. Creating your program will look like this on the Unix screen. You'll log into your account, and you'll call up the VI text editor to enter and save source code file. And to do that, at the prompt, you'll type VI space and the name of your program. Once you're inside VI, you must always remember to press the A key immediately. This places you in edit mode. If you do not press the A key, then you're still in command mode, and the text that you type will not appear on the screen. VI will try to interpret it as a command. You'll use the arrow keys to navigate. It's rather primitive. Type your code, and when you're finished, press the escape key to put you back in command mode, and then type Z to save under the name that you designated. Now your code is saved with the file name hello.c or whatever name you gave it, and you're returned to the Unix prompt. So here you are in VI, Save your code, and when you return to the Unix prompt, use the ls command to verify that the new file is there. Then attempt to compile it by typing gcc space and the name of the file. If the compilation is successful, you will not receive a message. You'll just get the Unix prompt. Then you should type ls again to verify that the executable file is there. And here we see a.out has appeared. Next we'll run a.out by typing /a.out and make sure the program does what it's supposed to do. Test it with a variety of inputs, if applicable. To submit assignments, you'll create a directory for your project or assignments. You'll navigate into that directory using CD and create all of your codes and files. And when you're finished with the assignment, move up the hierarchy by one directory and create the archive file with the tar command. This will archive the entire directory. And then submit the archive directory to my Dropbox. And be sure to have space after CP and a space between the file name and the path of the Dropbox. Here again is the Hello C program that you should try as your first program. These are questions that you should be able to answer following this module.